This is the solution video for the Algebra revision worksheet. On the first page we have quadratic inequalities. In each case the first step is going to be to factorise the quadratic. Make sure not to slip into equal signs by accident. In the first one it's quite tempting to write down x minus 2, x minus 3 as your factors, but watch out, the correct factors in this case are x plus 6, x minus 1. Sketching your solution will help you to decide on the direction of the inequality symbols. If I was to solve this as normal, x would be equal to minus 6 and x would be equal to 1, so they're the roots that I've marked on my diagram. I note that the question says greater than 0, so I'm looking above the x-axis. I'm moving to the left of minus 6 and to the right of 1. So x is less than minus 6 and x is greater than 1. On to question 2. First I'll factorise and next I'll sketch. Again, refer back to the question for the inequality symbol. Less than or equal to 0 indicates I'm looking below the x-axis. And this highlighted region is to the right of minus 11 and to the left of minus 1. So notice that I choose inequality symbols that point in those directions, to the left of minus 1, to the right of minus 11. Because this is one continuous portion of my diagram, I can write my answer as x being between minus 11 and minus 1. Just notice there that there's an equals part in the symbol in the question, so I ensure that there are equals parts in the solutions as well. On to question 3. First I'll factorise. This time it was a difference of two squares factorisation, and next I'll sketch. Again, this time I'm looking at less than 0, so I'm below the x-axis. X is to the right of minus 1 and x is to the left of 1. And again, I can write it as one statement if I wish. Question 4. First I'll factorise, then I'll sketch. I'll note the inequality symbol. Greater than or equal to means I'm looking above the x-axis. So I'm going to the left of minus a half, so my less than or equal to symbol points left, and I'm going to the right of 5, my greater than or equal to symbol points right. Two separate parts of my graph are highlighted here, so I won't merge my answer. On to question 5. First I factorise, next I'll sketch. Again, I'll refer then to my inequality symbol. So I'm looking above the x-axis. X is less than minus 1 and x is greater than 5/3. In each case here, I've gone straight to the factorisation of the quadratic, the final line of that, but obviously feel free to do this step by step as needed. And I'll actually go through it step by step for question 6. So first I'll need to find the guide number, and I'll do that by multiplying my first value and my last value together, my coefficient of x squared and my constant, give me a guide number of 4 this time. Then I'll factorise that 4, and I'll look back to my middle term. My middle term is minus 5, so can I make a minus 5 out of these? I can say minus 1, minus 4. And so I split up that middle term then, minus 5x into minus 1x minus 4x. Now I'll factorise each of the separate parts, starting with my first two terms, minus 2x squared minus 1x. So I can factorise out minus 1x, and that'll leave me with 2x plus 1. And I can factorise minus 2 out of the second pair to give me the same result in the bracket. Just note, if you factorise out 1x, your signs would be different in here, and if you had done that you would have factorised out plus 2 to get matching brackets in these two positions. So I end up with a factorised quadratic of minus 1x minus 2 by 2x plus 1 less than or equal to 0. Now I'm back again to do my sketch, and I just started drawing a U-shaped curve, but actually look back. We've got a negative x squared, so we should be drawing an n-shaped curve. Let's look at our solutions. I'm getting minus 2 and minus a half. I go back and look at my inequality, it's less than or equal to 0. So I'm looking below the x-axis, I highlight that portion of my graph, and you can see I'm going to the left of minus 2 and to the right of minus a half. And again, because it's an equals part in the original quadratic, I'll include an equals part in my symbol here. I keep them separate because it's two separate parts of my diagram. We'll be using some of these skills again in the rational inequalities part of the worksheet. But first of all, I need to rewrite my original statement because I can't deal with this rational part of it. I don't like the fact that there's a fraction, so I want to get rid of it. So the step that I'm going to take if I have a question like this is that I have to multiply both sides by the denominator squared. It's very important. Don't just bring the denominator across and multiply it. You can't do that in this case because of the inequality in the question. So I multiply both sides by that, and you can see there on the left-hand side that the x minus 1 on the bottom will cancel off against one of the x minus 1s from the x minus 1 squared. Obviously here in this case on the right hand side that's just going to resolve to 0. So actually this one's quite nice because it ends up that I almost have my quadratic factorised for me. Normally I might have to multiply out and do a bit of rearranging in order to get to this stage. But at this stage, I can see that I've got my two brackets. Less than 0, I'll just go straight to drawing my sketch in that case. So I've drawn my sketch, go back again and look at the inequality symbol. I'm looking below the x-axis, and because it's one continuous portion of the graph, I can write it as x being between 1 and 7. I might expect a little bit more work now in question 2. Again, same idea to begin though, I'm going to multiply both sides by the denominator squared. Again, a bit of cancelling is possible. And next I'm going to want to expand that, so just multiply it out and just take care with that, because obviously you've got to square, for example, over here before I multiply by -2. So I've started my expansion here, and I can see that it's going to resolve into a quadratic. I'll bring everything to one side, to the left, and when I tidy it up, I'm going to have 5x squared plus x minus 6 is less than or equal to 0. And now I'm back to the same type of thing again. I'm just going to want to factorise this sketch and decide my final solution. In this case, my factors are 5x plus 6 by x minus 1. I'll draw my sketch, note my inequality symbol. Writing down my solutions, I'm going highlighting to the right of -6/5, so greater than or equal to, highlighting to the left of the 1, so less than or equal to, again, one continuous portion, so I can write it as one statement. And then on to question 3. As before, I've got an inequality, and it's a rational inequality, which just means there's a fraction in it, and particularly a fraction with an x in the denominator. So I'll multiply both sides by the square of that denominator. Again, the denominator itself is going to cancel out against one of those x minus 3's in the square, and then I have to multiply out. This looks like it might turn into a cubic. So I'll tidy it up. Okay, so I've got a cubic, I've got a test for a root. I'll figure out one solution by trial and error. So if I stick -1 in for x, I get a result of 0, so that's definitely a root. So x plus 1 is a factor, so I'm going to factorise my quadratic, or sorry, my cubic now, and divide into my cubic. I'll stick x plus 1 out here as a factor. I'll put in my first and last terms into the array, and then I'll start dividing. So what am I going to get? Well, I'm going to get an x squared here, and then x squared by 1 is plus 1x squared, and plus 1 by plus 12 gives plus 12 inside in the array. And this then should be plus 12x by multiplying the outside terms. Looking back to my cubic again, I want to get plus 5x. So I'm going to have to take away 7x here. And I'm at plus 1x squared, but I want minus 6x squared, so I'll have to take away 7x squared there, which means that I'll have to have minus 7x on top. So now I've got a quadratic, and I'm going to have to factorise that. When I factorise this, it factorises quite straightforwardly as x minus 3 by x minus 4. Now, watch out, because I don't just have two factors, I don't just have a quadratic, I've got a cubic. So when I'm sketching this, I have to take these three factors into account. Thinking of the roots, -1, 3, and 4. It's a cubic. What does a cubic look like? Like this. We go up the hill first. I'm filling in all my roots there. Back now to the inequality to figure out what symbol I'm looking for. I've got less than 0. I'm looking below the x-axis. So my solution has a couple of bits there. X is less than -1 and x is between 3 and 4. Okay, back up then to question 4. Multiplying both sides by the denominator squared. So once I've done that, I'll cancel off as before. This y minus 4 will cancel off against one of the y minus 4's in the square. And then I'm going to expand. Again, just take care with your squaring. It's the most likely place to make a mistake. I'm expanding there a bit more, and then I'm going to bring everything over to the left-hand side and tidy it up into a quadratic. Tidying up my quadratic then, and next my job will be to factorise. Let's go through this one in a few steps. So we've got our guide number of 76. I'm going to factorise that, and I find that 4 and 19 will be an appropriate choice of factors from that 76. So I'm going to go off now and factorise this guy here, or at least break up my 23. And then I'll factorise the first two terms, and then the next two terms. And then my overall factors of the quadratic. And now it's back to sketching and deciding on my solution. Again, watch out here that I'm looking at a negative coefficient on the y squared, so I'm going to be drawing an n-shaped curve. Don't forget to check out the inequality symbol. I'm looking at greater than or equal to 0. And notice how it's one continuous stretch. So I can write my answer as one statement. On to question 5. I still have a variable in the denominator, so I'm still dealing with the same approach, timesing both sides by the denominator squared. This one should probably tidy up quite nicely. So I'm multiplying both sides by a squared. Notice again, the a in the denominator will cancel off against one of those a's, and then I'll multiply out and tidy up a little bit. So I'll bring everything over to the left-hand side. Notice how I've got no constant. Quadratics where there's no constant are the easiest type to actually factorise, because if you look, each of the terms shares a factor of a, So all I have to do is factorise that out. When I go to sketch this, it just means that this a is equal to 0 in the diagram. Observe as well that I've got a positive coefficient on the a squared, so I'm back to the U-shaped curve. So I've got my sketch and I've got my roots marked in. I've got less than in my original quadratic, so I'm going to go and look at underneath the axis. Again, it's one continuous part of my diagram. So a is between 0 and 1/4. Just make sure that you're using the correct variable too. Obviously, a lot of the time you'll have x's, but sometimes you're going to end up having y's or a's, so use them as appropriate. Okay, last question. I've multiplied both sides by 5 minus 2a squared. I'm going to cancel off that denominator against one of those, and I'm going to multiply it and tidy up. So I have part of my expansion done here, a bit more to go. I'm going to get everything over to one side. So the quadratic that this resolves into actually works out to have quite a nice answer, but looks horrendous in terms of factorization. So the sensible option to do here is just use the minus b formula and then see what you get. So we've got our a, b and c values, and when you work this out, you'll draw an n-shaped curve because of the negative coefficient here, and you'll mark in your two solutions. And they are 17/9 and 5/2. Now you mightn't be sure which one to put on the left. So the easiest thing to do in that case is simply go to your calculator, type in both the fractions, 17 divided by 9 for example, hit the SD button, it's 1.8 recurring, fine. And then we've got 5 divided by 2, so you'd hardly need the calculator for that. That's going to give you 2.5, so obviously the 1.8 recurring is further to the left. That tells me where to fit it in the diagram. Let's have a glance at our inequality symbol. We've got less than or equal to, so we're looking below the axis. So I'm going to the left of 17/9 and to the right of 5/2. So my less than or equal to symbol looks like it's pointing left, and my greater than or equal to symbol looks like it's pointing right. So I've got my solution. A is less than or equal to 17/9 and a is greater than or equal to 5/2. Do really watch out in these rational inequality questions. You absolutely have to make sure to multiply both sides by the denominator squared. If you don't, you're not going to get all your correct answers. Remember to draw your sketch at the end to determine what the correct direction of your inequality symbols is going to be in your final answer.